Hello everyone, you might have heard the term clock speed, but do you really know what actually it is? Well, if you don't, then stick around because this is the topic of today's video. Ready? Let's begin. In computing, clock speed is also known as clock rate or clock frequency. The rate at which a processor can execute instructions is called clock speed. Processor's clock speed determines how quickly CPU can retrieve and interpret instructions. This helps the computer to complete more tasks by getting them done faster. Every computer contains an internal clock that measures the rate at which CPU executes instructions and synchronizes all the various components. CPU requires fixed number of clock cycles to execute each instruction. So basically, clock speed is the number of cycles that the processor executes per second. Now you must be thinking about what is a cycle, right? Well, it's the basic unit that measures the processor's clock speed. The faster the clock, the more instructions CPU can execute per second. Technically, we can say clock is a regular on and off electrical pulse. Each time the pulse goes from on to off, then back to on again is one cycle. During each cycle, billions of transistors within the processor open and close. Now the question is, how processor's clock speed is measured? Well, it is typically measured in megahertz and gigahertz. 1 megahertz is equal to 1 million cycles per second, and 1 gigahertz equal to 1 billion cycles per second. For example, a CPU with a clock speed of 4.2 megahertz execute 4.2 million cycles per second. A CPU with a clock speed of 4.2 gigahertz execute 4.2 billion cycles per second. This means 4.2 gigahertz processor has twice the clock speed of a 2.1 megahertz processor. Now let's break it down into further details. As I have mentioned above, the speed of the CPU clock determines the number of instructions it can perform in 1 second of time. However, the speed of the CPU clock can be increased by overclocking. Overclocking a CPU can increase significant performance but requires more power and generates more heat. So as you raise the clock speed, there can be stability issues and your system might get crashed. So in order to keep the processor away from overheating, it will strangle down to a lower frequency when it gets too hot. And sometimes overclocking may also lead to overvolting. It happens when you raise the voltage given to the chip in order to increase the clock speed. Apart from overclocking, turbo boost technology also enables the CPU to safely and efficiently increase the clock speed beyond its usual operating limits. Most modern CPUs work on a range of clock speeds, from the minimum base clock speed to a maximum turbo speed. When the processor encounters a demanding application, it raises its clock speed temporarily to get the job done faster. However, higher clock speeds generate more heat, just like overclocking does. So in order to keep the processor away from dangerously overheating, it will throttle down to a lower frequency when it gets too warm. So if you have a better cooling system for your CPU, it will lead to higher sustainable speeds. Now here is an important part of the topic. Higher clock speed typically means that a CPU can process more instructions per second and therefore can perform better on tasks that require fast processing, right? Unfortunately, this is not the case. Let me tell you why. When you buy a new computer, you normally check its processor's clock speed or frequency, such as 2 GHz, 3 GHz, 4 GHz and so on. And you think it's the fastest computer, right? Absolutely not. Its clock speed is just a good indicator of performance, and it's not the only one to consider when deciding if a computer is fast enough for you. Other factors also contribute to the overall performance of a computer, such as number of cores, bus speed, cache size, speed of RAM, and HDD or SSD speed. Therefore, while the processor's clock speed is a significant indicator of how fast a computer is, it's not the only factor that matters. Now, it's also important to note that sometimes multiple instructions are completed in a single clock cycle, while in other cases one instruction might be completed in multiple clock cycles. This is because CPUs come in different designs and architectures that deal with the instructions differently. For example, a CPU with a higher clock speed from 5 years ago might be outperformed by a new CPU with a lower clock speed, because the newer technology handles instructions more efficiently. Okay, so the bottom line is buying a computer with multiple cores and a super high clock speed sounds ideal. Alright, I hope this informative video will help you. So with that, this brings me to the end of my topic. I will catch you in the next video. Make sure you hit the subscribe button.